Narasimhareddy, Education Society's group of institutions, integrated campus. The institution is approved by AICT New Delhi and affiliated to JNTU Hyderabad. This is Dr. G. Subbarao, professor, working in Department of Civil Engineering. I welcome all the civil engineering candidates for this online class. In today's session, I am going to speak about hydrological cycle and effects on overuse of groundwater. So let us continue the topic with the hydrological cycle. The more we know about water, the better we can manage the resource. So it's better to have an idea about water to manage the resource for even future purpose. About 97% of world's water is saline water, that is salt water, and this saline water is available only in the seas and oceans. 2.6% is tapped in polar ice caps and glaciers, whereas only 0.4% is available as fresh water. This is the scenario. If we see the table from the oceans, that is the salt water, which is occupied by 97.24% and 31 crore 70 lakhs in cubic miles, that is the volume, and 2.14% is ice caps and glaciers, which is 70 lakhs cubic miles of water, and groundwater is 20 lakhs cubic miles, 0.61% is freshwater lakes, 30,000 cubic miles as a water volume, and 0.009% of total water, whereas 0.008% is inland seas, 0.005% is soil moisture, 0.001% is atmosphere, and rivers contributes 0.0001%, and the total water volume is 32 crore 60 lakhs cubic miles, that is 100%. So this is how the Earth's water supply. So in the entire Earth's water supply, usable water is only this much, that is nearly 0.3% only. So unusable water content is 99.7%. This is the unusable water. If we see this usable water once again, wherein rivers, freshwater and groundwater contributes. Freshwater occurs mainly in two forms, namely groundwater and surface water. So the distribution of freshwater is geographically not even, and it varies greatly from country to country, region to region, place to place. Groundwater is one of the components of the hydrological cycle in nature. So hydrological cycle enables a clear understanding of recharge, storage and movement of water in the subsurface. Hence, it is necessary to understand the hydrological cycle to understand the recharge conditions, storage conditions and movement of water in the subsurface. Water is continuously moving around the earth, through the earth and above the earth. How? It moves as water vapor or liquid vapor and even ice, and constantly changing its form, vapor to liquid or liquid to water, water to vapor, vice versa. So the movement of water is referred to as the global water cycle, that is called hydrologic cycle. precipitation, evaporation, transpiration, and runoff are the primary phases in the hydrological cycle. So to understand the hydrological cycle, one must know about precipitation, evaporation, transpiration, and runoff. Runoff means surface runoff as well as subsurface infiltration. So the global water budget is based on the recycling of Earth's water supply. That is how the water is moving, storage, and transfer. The continuous circulation of water, either from land or from water bodies such as streams, rivers, lakes, ponds, and this water joins the atmosphere and finally condenses into the form of precipitation. So the continuous circulation of water joins the atmosphere and finally condenses into the form of precipitation. What is condensation? The conversion of vapor or gas into a liquid is called as condensation. So if you see the picture, the water is evaporated from the seas and oceans and stored in the atmosphere as clouds, and the clouds condense so that the clouds are consist of vapors or gases, and when condensation takes place, this vapor or gas turns into liquid. So condensation is a process in which water vapor, that is gases formed in the air, changes into water when it comes in contact with the cool surfaces and is the reverse of vaporization. So entirely reverse for evaporation. This is how water is falling. So the components of hydrological cycle, if you see, P, R, I, E, T. So P stands for precipitation, R stands for runoff, I for infiltration, E for evaporation, T for transport. Let us see the precipitation. Water usually enters the surface through the sediments as precipitation in the form of rain or snow or sleet or hail. So any kind of weather conditions, falling from the sky. So something is falling from the sky in the form of rain or snow or sleet or hail. So this is how precipitation is taking place. Runoff. The surface runoff by means of streams or rivers means is the flow of water on the ground surface when rainwater takes place or storm water takes place or meltwater. So that infiltrates into the soil. Runoff occurs when there is more water than land can absorb. So whatever the rainwater is there or snow water is there, that is absorbed by the land, and excess water that flows on the surface of the land. So the excess liquid or excess water flows across the surface of the land into nearby creeks or streams or ponds. Runoff can come from both the natural process and a human activity. This is a natural process of surface runoff. That means a river is flowing. This is a natural process. Whereas human activity means the water which is released by the human beings from the houses or from the industries, etc. So the most familiar type of natural runoff is even snow melt. Infiltration. We know very well the components of hydrological cycle consists of precipitation, runoff, infiltration, and evapotranspiration. So infiltration, that means water entering into the ground. Infiltration is the process by which water soaks into the subsurface soil or rock and moves into the rocks through the pores which are present in the rock or pores which are present in the soil. So this is infiltration. Evapotranspiration. Evaporation means turning from liquid into water vapor. So liquid into water vapor. This is evaporation. And transpiration means is the process where plants absorb water through the roots and give off water through the leaves. That is transpiration. So in the entire process, a part of water is lost by evaporation from the seas or oceans, and certain portion percolates into the ground to form groundwater reservoir, and the remaining water flows on the ground as runoff and joins the streams and rivers and finally into the sea. So this is called the hydrological cycle. So this cycle is continuously repeated in the nature. Now, uses of water. Why water is required? So water is needed for daily purposes. Even water is required for organisms, for irrigation sector, industry sector, for producing electricity, and for even domestic uses. Hence, water is an important resource in all economic activities, ranging from agriculture to industry sector. Domestic use. Water is used for the purpose of drinking, bathing, washing, cooking, and sanitary. The recommended value as per Indian standard specification for domestic is 135 liters per day for human being. Industrial use. Water is required for various industries such as cement industry, mining industry, textile industry, leather industry. So, water is mandatory for industrial purpose. Public use. So, public utility purposes such as watering parks, flushing streets, jail sets, etc. require water. That is called public use. And water is used in case of any accident takes place or to prevent fire issues. So that is for fire use. And to grow the plants or crops, which is the main source of food, is required for irrigation purpose. And to produce electricity, so water is required for hydroelectric projects. Effects of overuse of groundwater. Lowering of water table. What happens if water is used in excess quantity? So the water table goes down. That is called lowering of water table. Excess use of groundwater for drinking purpose or irrigation purpose or domestic purposes, whatever it may be the purpose, results in rapid depletion of groundwater. And it leads to lowering of water table so that ultimately the wells become dry. So excessive use of groundwater for any purpose result in rapid depletion of groundwater and leads to lowering of water table and also drying of wells, maybe a borewell or open well. Sometimes when water is extracted more in more quantity, ground subsidence takes place. When groundwater withdrawal is more than its recharge conditions, so that sediments which are present in the aquifer become compacted. So this is called ground subsidence. Ultimately, it causes for damage of buildings or destroy of water supply systems. Why the shortage for water? There are so many reasons for shortage of water, which include increase in population, increased demand of water for various purposes, and unequal distribution of fresh water because it's not available everywhere equally. Increasing pollution of water sources cause overexploitation, and people totally depend on groundwater as it is considered to be fresh water. These are some of the reasons why shortage for water. Thank you.